And start recording here. Okay. Okay, we got George and Paige and Anna. Okay. And who is JJ Will? Can you undo? Hey guys, can I ask a favor of you from this point on? When we start class, which is what we're going to do now, can you, if you have a video, can you go ahead and enable your video? Because it's so much nicer lecturing to people rather than black screens, you know? Excellent. Hi, George. How are you doing? So, George, where are you? Are you overseas or? I can't hear you.
I'm in Puerto Rico right now.
Oh, okay. Wow, that's an interesting place to be. The hurricane season is off the hook. We've been really lucky so far. So
yeah, it's been not too bad.
Fingers crossed. Oh, okay, no problem. Yeah, I'm the same way, James. For some reason, my username has one T in it, which I hate, and I can't change it. So, okay, let's go ahead and get started. So, what I want to do today is I'm going to use those PowerPoints that I put up for you guys. And what I want to do is I want to go through this thing called, and you guys can all see my screen, right?
Yeah.
Okay, so what we want to do is we want to go through the same process we did for a categorical variable, except this time I have a quantitative variable and I want to ask myself, how do I get information out of it? And so what we're going to do is we're going to look at 3 different data sets. Those are the ones that I posted. I'm going to ask also that, you know, when I post the data sets that you guys can download those and have those ready. Working along is really important. You can go back and watch the video, but sometimes things happen when you're on your computer and then I'm not there. And if you do it, you know, while we're having class, you can stop me and say, hey, this isn't working, and someone else may have that same question, okay? So here's the goal, and this is an important take-home lesson from statistics in general, which is that the whole point of the sample is that samples estimate populations. And we saw that before when we talked about statistics and parameters, right? We said that we can't get the population parameter. So what do? We take a sample and we compute an estimate, okay? And that's one way in which samples estimate populations. But they also estimate populations in the sense that I'd like to know what the distribution of my values are in the population. Okay, in other words, a distribution, what does it tell me? What does it mean? Well, it tells me the values my variable can take on. So this is a plot of SAT critical reading scores, and the little you know, bars that you see here. This is a histogram from data, and this curved line is what we think the population looks like. And this distribution tells us the values the variable can take on. So SATs can go from, well, I don't know if it's 0, but here it looks like it's 320 to 800, okay? It also tells us how likely it is to take on a certain value. So you can see that we're really likely to take on values around 540, right? We're not very likely to take on values around 780. And so there's 2 goals that we have here. First, and this is the important goal of what we're going to try to do today, is I want to try to find out what that nice smooth curve is. Okay, I want to try to visually estimate what that curve for the population is. Okay. And how are we going to do that? Well, we're trying to find some curve that kind of evenly cuts through the data. You could think of it like kind of like a best fit function, right? And you can see that this process is not perfect, right? I mean, there's kind of gaps here, but this would be our best you know, function that kind of fits the data. The other thing we want to learn how to do is we want to learn how to describe this curve, okay? And that's where we start to get into that last step in exploratory data analysis. Which brings us to this process that we're going to use. And this is exploratory data analysis. This is the same process we're going to use the same steps that we used for categorical variables. And again, an important take home from this course is that whenever you have data, doesn't matter if it's categorical, quantitative, you have a whole bunch of variables, we always use this 4-step process. So first, we inspect and clean the data. Okay, you should never assume data you get from someone else is good. Okay, you have to visually summarize the data, which means we're going to plot it. And then we're going to numerically summarize. And what we're going to try to do here is we're going to try to compute numbers that capture key features of the plot. Okay, if you want to describe the plot to someone, how do you do that? It's really challenging, right? And this brings us to our last step. I want to put together what I get from the plot and put together what I get from the summary statistics in step 3 and give an overall description. And you might think this is exactly the same as what we did for categorical variables. And the answer is yes and no. It's the same steps, but what we're going to do in each of those steps is very different. So for example, with quantitative variables, we have outliers. We do not have outliers with categorical, right? When we visually summarize, when we make these plots, there's 3 different types of plots. And you might say, oh, well, for categorical, we had 4. But remember, with those 4 plots, okay, we were plotting the same thing, just different ways. Here we're going to see these 3 plots for quantitative variables are very different in nature, okay? And the plots have more information, which means that the summary statistics I'm going to compute to capture those main features of the plots are also going to be more complicated. And this is where we get into the center of the data set and the spread, right? And so lastly, we bring it all together. So when I ask you on an exam, describe the data set, you're going to give me 5 things. And these are the 5 things. And what we're going to do today is we're going to learn how to do these with actual data sets, okay? This is something that you can't sit here and watch somebody else do. You have to do it yourself. So this brings us to what we're going to do today. And by the way, so we're going to learn how to do this properly, okay, with the data set. We're going to learn how to interpret what each of these things means and why they're important. And these last 2 are pretty much in the lectures, okay? One of the things that's important to understand about statistics is that everything we do has a process. I mean, everything we do has a purpose. Sorry. In mathematics, that's not true. Your teacher says solve for X. What is X? Who knows? It could be anything. In statistics, every single thing we do in this class is applied. There's a reason why we're doing it, okay? Okay, so we're going to work with a few real data sets. We're going to learn how to do these 4 steps. And along the way, we're going to try to illustrate some key concepts here. So let's look at our contestants. The first data set we're going to look at is called heights, okay? This is data, to give you a little context here, this is data that was collected by Sir Francis Galton. He was an early statistician back in the late 1800s. And he was interested in understanding if certain attributes of parents were related to attributes in children. And the one particular one in this data set is height. So he wanted to see if the heights of the parents were related to the heights of the children and how. However, we're going to look at a single variable. We're only going to look at just the heights of the male children. We're not going to look at relationships. So what I have in this little PowerPoint is these 4 steps on different slides, okay? So we're going to go ahead and we're just going to kind of fill in the blanks as we go along. So let's look at this data set. This is the heights of the male children. I've already brought this into Excel. And I'm interested in the data in this 3rd column. And so the first step is what? I want to inspect and clean, right? So what I always do is I sort the data values. Okay, so when I'm in StatCrunch, I leave this be, and I pick the variable that I want to sort, and I click compute. And what am I looking for? Well, the first thing I'm looking for, and the most important thing, I'm looking for invalid data values. In other words, excuse me, data values that aren't possible. So what would be an example of an invalid data value? Let's see, I'll pick on somebody. Let's see, Taylor, what do you think? What would be an invalid data value for height? Taylor, can you hear?
Yeah, I can hear. My apologies. I'm still trying to get everything loaded on. I was a little late coming into class.
That's all right. It's okay. Taylor, so why don't we while you get ready, let's go ahead. We'll pick on someone else. Anna, what do you think an example for an invalid height would be if you were looking at this data set?
Maybe like negative, because no one can be negative, a negative height.
Negative height, or someone that was 12 inches tall, right? You would know that that's wrong. So here we're starting off at 60 inches, which is 5 feet. That looks okay. And I'm just going to look through here, and I don't see anything obviously suspect. Okay. And we go all the way down to the bottom. And at the very bottom, and it's hard because I got too many windows open here. At the very bottom, I think it's like, move you guys over here. Oops, hold on. I clicked on something I didn't want to. There we go. Okay, so the very bottom is going to be like 79 inches. Let's see. Yeah, 79 inches. So that's fine. Okay, so 79 inches, 72 inches is going to be 6 feet. So that's like 6 feet 7. Okay, so that's possible. Okay, so nothing really crazy there. Okay, so invalid data values, we have none. I'm going to postpone outliers till we get to the graphing, okay? Because the way that we typically get outliers is we use the graph. Sometimes it's obvious, like if you go back and you look at that Major League Baseball home run data set from 1920, you know, you have 19 home runs, and then all of a sudden you have Babe Ruth at 54. That's obviously an outlier, okay? But here we're going to go ahead and plot it. Missing data values, we have none. Okay. And if we did, we wouldn't do anything about it. Okay, so that's pretty much it for the inspection, okay? The hardest part, like I mentioned in the lectures, is trying to distinguish between invalid and outliers. And I'll try not to give you any situations where that becomes a major issue, because usually you have to actually go back to the source when that happens. You can't generally resolve it on your own anyhow. Okay, plotting the data. So we have 3 options. Which one do we use? Well, when we have small data sets, and small is kind of a vague term, but usually less than 20 data points is considered small, we use a dot plot. And you can think of a dot plot as like a high-res picture. In other words, if someone was to take a picture of your face and they were literally to resolve it at the pore level, okay, that's what a dot plot is, okay? But we usually don't work with data sets that are that small. And part of the reason we don't is because we want to use the data to make generalizations about the population, right? That's kind of the point of what we're doing. If you only have 20 data values, usually your sample's too small. So usually we're not going to work with dot plots. Histogram is usually what we're going to work with. And you can think of this as like a medium res picture, okay? Box plots, we generally don't do. We usually use box plots for kind of like diagnostic reasons. Later on, we're going to talk about the shape of the data, and it turns out that to determine symmetry or to detect outliers, box plots can be good. And this is because this is a really low res sort of picture. This is like going out into outer space. and taking a picture of the Earth, very low resolution. And this goes back to my statement I made before, which is, yes, we have 3 plots, but they're plotting the data in very different ways. So let's go make a histogram of this data. And I'm just going to hover over graph and select histogram and click on that. And I'm going to choose my variable. So I want height of child. I'm not going to mess with any of this. I'm going to leave frequency. And so this is where categorical and quantitative are a little different. Remember we said when we have large data sets with a categorical, we like to plot percentages. We're going to keep this as frequencies, okay? I'm going to put value over bars and the mean and the median. And that's usually a good thing to put into your plot. You don't have to, okay? One thing you do have to put in, which is very important, and this is something that you'll definitely lose points for on an exam, you have to put in the axis labels. Okay, so on the x-axis, I'm plotting the variable values, right? So these are going to be heights in units of inches. My Y label, you can plot frequency or counts, okay? I'm just going to plot counts. You could plot frequency. I mean, you could put frequency, it doesn't matter. And now I have to put a title. And what I want to do is I want to create a title that's going to be self-explanatory. That is, a person can look at this graph and understand what they're looking at without having to read anything else. So I'm just going to put distribution of heights for male children. Okay. And I'm going to click compute. And there we are. Now the question is, what is it that we want to pick out about this graph? What is it that you want to tell other people? You're in the elevator with your boss and he says, hey, you looked at that male children height data. What did it look like? What are you going to tell him? Well, there's 3 things you're going to tell him. You're going to tell him the number of modes. In other words, the number of humps, right? And if we go back to the PowerPoint handout, remember what we're trying to do, right? We're trying to basically put it in one of these rough sort of boxes, right? Oops, I'm in the wrong PowerPoint, sorry. We're trying to say 1 hump, 2 humps, no humps, or multiple. Now you got to be careful. Okay, notice that the data is not nice. The data has variations in here, okay? So if you look at this, this is really unimodal. This little thing here, can you guys see where my cursor is hovering over? This is not a mode, okay? This is due to the binning. In other words, how I chose those little bin widths there. So the person that plotted this did not do a good job. What we want to do is we want to go back, and because if you look at this picture, for example, there's a question as to how many modes. Does anyone want to take a guess as to how many modes? Anybody? 0, 1, or 2?
I think there's 2. That's my guess.
Okay, so you might think this is a mode and this is a mode, right? Mm-hmm. Okay. Yeah. Any other options here? We got a vote.
1.
And so here's the thing: how do we resolve this? Okay. So when it looks like there's a lot of modes, what we're going to do is we're going to increase the bin size a little bit. What I want to see is when I change this bin size, does this still appear to be a mode, or does it kind of average out? Okay. Notice that if I change the bin size, it's probably going to get a little bit of averaging out. So let me show you what I mean. I'm gonna plot this 3 ways, okay? And you don't have to do this right now, but I'm gonna go down here to bins, okay? And it asks you, where do you want the bin to start? Well, my lowest height was 60. And I'm gonna make the width 0.1, okay? In other words, I'm going to group people that are 0.1 inches from each other. And you can see what happens, right? The graph gets really choppy. The resolution's too high. So this is an extreme of a terrible plot. What's going to happen as I increase the bin width is things are going to start to average out, right? See this little bar here and this big bar? They're going to average out, and this graph's going to become smoother. And what I want to do is I want to increase the bin width until the point where it looks like I can draw a nice smooth curve, okay? So we just play. I'm going to increase it to 1. Still a little choppy, okay? And I might be able to get rid of this by increasing it a little bit. So let's go to edit and let's change this to 2. Okay. Now, how many modes do I have? There's only one. This is clear, right? One mode is right here. So when we change the bin width, it helps us get a better picture of what's going on. So let me go back and show you really quick. So the person who plotted this, okay? The person who plotted this data in the beginning, and it wasn't me, by the way. They kind of did a bad job, right? They should have got rid of some of this choppiness by making the bins a little wider, and it would have smoothed things out, all right? Do we have any questions about that? I know that's kind of a new skill. Does everyone feel comfortable with that? Okay, I'm going to take that as a yes, okay? Okay, so we clearly have unimodal. What I'm going to do is I'm going to go ahead, I'm going to paste this. So when you want to copy and paste, just right-click and copy image. And then I'm going to go wherever I want to copy it, which is down here. And I'm just going to paste it. And I'm going to paste as a picture, okay? And you just resize it. And of course, if I was doing this in real life or I was doing this for a grade, I'd probably want to make the title and maybe the axis label a little larger, but that looks fine. That's good enough. Oops, didn't take. Okay, and there we are. So we know that this is unimodal, okay? I'm going to go way down to here. I'm going to go to the very last slide. And what do we want? We want the number of modes, right? So I'm going to start off saying it is unimodal, one mode. And now I want to determine the shape. So what am I trying to do? Again, I'm trying to roughly categorize the shape. I want to put it into one of 3 bins, okay? And by the way, I'm going to mention something very quickly. When you have modes, so I said this before, okay, everything we do has a purpose. There's a reason. Why are we interested in the modes? The modes indicate subpopulations. So you might remember this slide from the lectures where this is the average drive of all golfers. The key here is all. Male and female are included, okay? So one other way to check the number of modes is to ask yourself, do I have another factor like gender that might create 2 subpopulations, okay? Now that could happen in this data set. I mean, what if they collected really young children and really old children, right? It could potentially happen, but there's generally a reason why, okay? There's usually a subpopulation lurking in the background. Okay, so for shape, tail on the left, left skewed. Tail on the right, right skewed. Kind of symmetric, okay, kind of even on both sides, the same on both sides. And we're going to put it into one of these 3 bins. And so the question is, I think I can still paste, can I? Yeah. So the question is, which bin, oh, excuse me, let me go back. It caught everything else here. There we go. So if I just look at our plot we made, which bin does it go into? Is it left skewed? Is it right skewed? Or is it symmetric? What do you think?
Is it right skewed?
Okay, we have one view for right skewed because you're seeing this tail out here, right?
Yeah.
Okay. And anyone else?
I think it's right skewed too.
Okay. And so here's the question. How do we tell for sure? Okay. So here's how we tell for sure. And by the way, when you get a data set that comes from a population where that actual curve is symmetric, it rarely looks symmetric. If it does, you should actually think about whether or not the data is fudged, okay? Because it never looks nice and symmetric. Okay, let's go back and see how we determine this for sure. There's two ways we can determine symmetry. The first is, remember that when the data set is symmetric, the mean is equal to the median. And these two lie on top of each other, okay? So I'm going to go back to my handout here. So when we're looking at shape, okay, we can look at two things. We can look at if the mean is equal to the median, or we can look at the box plot. And this is where the box plot is actually useful. It's good in telling us if our data set is symmetric. This is usually a really good way of telling. Okay. And so I'm going to do that. I'm going to make a box plot also and look at it just to check myself. So we can see that the mean and the median are on top of each other. So that's pretty strong evidence that it is actually symmetric. But let's make a box plot too and see. So I'm going to go to graph, box plot. And I'll show you something that's nice. You can hit this thing called draw box horizontally, okay? And I won't bother putting in a title, okay? And this shows us the box plot. And I'm going to try to put them on the same scale so I can compare them, all right? So this starts down here at 60, okay? And it goes up here. Now, when you're looking at a box plot, how do you determine symmetry? You look at two things. You look at the position of the median inside the box. When you have a symmetric distribution, the median is kind of in the middle, okay? Because this is saying this is the 25% to 50% of the data and 50% to 75% of the data. They take up the same room, okay? The other thing that's pretty much the same are the whiskers, the length of these whiskers, okay? And you can see that they're pretty similar, all right? What's throwing you off visually are these outliers, or what it's flagging as outliers, okay? So this is actually a symmetric, we would describe this as symmetric. And actually it's very hard to tell, especially for a first-time student, just by looking at the histogram, okay? I could see students answering 3 different ways, to be quite honest with you, okay? But the box plot tells you unambiguously, along with the fact that the mean and the median are the same. Does that make sense, or do you want to review something in that line of reasoning? Everybody good with this? Okay. I'm going to go back to the PowerPoint then. Go ahead and put this in. So this is going to be symmetric. And now I want to report on outliers. And so this is where box plots actually fall down. Does the box plot indicate that I have any outliers? I'll call on somebody new. Let's see, I'll pick on Paige. What do you think? If I look at this bottom plot, this box plot, do you think there's any outliers based on the box plot?
Yes, because they're outside the whiskers.
Exactly. So these little dots, the box plot saying, hey, you have 4 outliers. Do I actually have outliers? No. Okay. These just match the criteria that we use in a box plot for indicating outliers. Sometimes people call these outliers in name only. Notice what they are, is they're just the end of a long tail. Okay. If we had a lot more data, we'd kind of flesh out this tail. When you have an outlier appears with a histogram, it actually appears very far away from the rest of the data. Okay. Let me show you really quickly an example of a situation where there's an actual outlier and how it appears both in the data. Give me a second here, make sure I get the right one. Yeah, it's the home run data set. So if you look at the home runs, okay, and I'm going to do this really quick. You don't have to do this. I just want you to follow, okay? I'm going to plot a histogram. And let me actually go back. I want to do something really quick. I didn't do something group by year. Yeah, okay. This is an outlier. See this here? Far away from the rest of the distribution. An outlier is an outcast, okay? Far away from everyone else. This isn't an outcast. This is, I mean, if you want to play around with language, this is on the outskirts, okay? It's still in town, but it's on the edge. So you want to be careful about that. And I can go back and fill this in. Questions that we have. Everybody's good so far?
So to determine for the outliers, we should focus on the histogram to see rather than the box plot.
Exactly. So the box plot is too sensitive to outliers. Things, if you have data that has really long tails, and you see that a lot with financial data, it will indicate that there are outliers, but they aren't, okay? And so what I'm going to do is I'm going to start to create a description. And I would go ahead and put this in your notes, okay? I'm going to insert a little text box here. Let me move this around. Where'd it go? Oh, there it is. Oh, come on. And you can use this on the exams or anything, okay? So we're going to say the plot first, we always say what it is we're plotting, okay? Is unimodal and symmetric with no apparent outliers. When there are outliers, okay, and I'm not going to, I'm not training you guys to be, expert statisticians, right? When there are outliers, what people generally report is they report whether they're upper or lower and how many. But if you just say outliers or no apparent outliers, that's fine, okay? I'm not going to be picky about that. Okay. So we've got the first 3 things that we need in describing a plot. Now we need the center and the spread, okay? So what you want to remember about them is when you have strongly skewed data or you have outliers, you use the median for the center, okay? And when you have symmetric data, you use the mean, okay, for the center. And this is what was going on in that Mr. Burns example, right? He had an outlier. And what was he doing? He should have been using the median, which would have been $1. That would have been really where most of the data values were centered around, right? But what did he do? Well, being the sneaky individual he is, even though he had outliers, he used the mean. And he said the average is 100. Let me go back to that slide just for a moment, okay? So when you have outliers, this is what's happening, okay? These are the 9 people that are making $1. There's Mr. Burns. There's the median, which is really where most of the values are centered around, right? That's why the median is a good measure for the center for this data set. This is the average, okay? Most of the data values are not centered. That's why we don't use the average. Okay, when we have skew, let me show you what happens. So see, the median and the mean are on top of each other. And what the tail does is the tail acts like an outlier. It draws the mean out towards it, okay? And the same is true for a right skew data set. The tail kind of drags the mean out towards the tail. And so this is some of the reading quiz questions, right? Notice that you can take the same data and give 2 different measures for the center, and one can be correct and one isn't, you know, if you're trying to fool people, okay? But we're not trying to do that. So how do we compute? So for this data set, it's symmetric, right? So I'm going to compute the mean and the standard deviation. And I'm going to do that by going up to stat, summary stat, and then choosing columns. Am I going slow enough for you guys to follow along? Or am I going too fast? The following along part's important because this is what you have to do on the homework. So tell me if I'm going too fast, okay? Okay, I click on this, select my variable just like always. The default is too busy. So I'm just going to click N. I always like the sample size. You don't have to choose it. I always like to know how big my sample is. And what I'm going to do is after I click on N, I'm going to hold down Control and click the mean. And you can see it says select more than one with Shift click or Control click. Holding down the Control key, I'll get standard deviation. And there are my values. The center here is given by the mean, and the standard deviation gives us the width. It's a measure of the width. And one of the things that's really cool about StatCrunch is I can just copy and paste this right into a document, like an exam, for example, right? Or homework. So if I rounded this off to the first decimal place, the mean is 69.2, so I'm going to highlight that and hit Control X. And we want to paste it down here. So the center here is the mean because we have a symmetric data set, and it's equal to 69.2. And the spread is the standard deviation, again, for the same reason, because it's symmetric. And it's equal to, and I'm just going to copy and paste this. So to the first decimal, it's 2.6. And just put that in. So StatCrunch is kind of cool. Okay. Now I have everything I need, right? I can fill in those last 2 blanks for my description. Okay. So now I can say, the center of the data set was given by the mean which is, and what do we say, 69.2, I think? Go back and check really quick. Yep, 69.2. Always a good idea to give units, okay? If you're talking to someone who's European, right, they're not going to understand, or they're going to think it's weird, right? And the width is given by the standard deviation, which is 2.6 inches. There are very few times in the class when I'm going to tell you, do it this way. This is one time. Okay, use this as a script, literally, okay? Because students have the hardest time. I can tell you on the final, the most commonly missed question is, describe this plot. And it should be a slam dunk, okay? And yet people go off on tangents. They think it means describe what they think they see, and that's not what this means, okay? So how's that looking? Anything we want to go back and kind of fill in or go over maybe? Okay. Well, hey, let's just keep on going then. Let's go to our second data set. And this will go a little faster now, right? Because we're pros at this. This is a data set I collected a couple years ago. I had a friend that was visiting and doing research for a couple of months. And he wanted to run a play, so I just thought it'll be fun. I'll have a data set for my class anyhow, right? So I went to Craigslist and I took a random sample from their listings and then got some information on the apartments. Okay, and obviously we're not interested in heights of male children. I'm interested in the price of apartments. Sorry about that. And so let's go ahead and look at that data set. So, move things around here. And here we are. Again, I'm going to go ahead and I want to inspect the data values, all right? So this is price, the first column, what I'm interested in. And I'm going to go ahead and sort. So there's price. All right, and so if I look at the data values, I have one apartment for 500. I don't know where that is, but it's possible. It's not invalid, right? And if I scroll down, the maximum price was 2,000. Okay, which is certainly possible. So we have no invalid data values, right? So if we go back and kind of fill in our blanks here, right? And outliers, again, we're gonna wait on outliers, okay? So we have no invalid data values. And so with missing data values, it's a little open to interpretation, right? Because if you go back and look at the data set, there's a lot of missing data values, okay? I'm just interested in this one variable. So for this one variable, I don't have anything that's missing, okay? If I was doing a more complicated analysis where I was looking at the relationship between, if you look at this guy here, this is Google ratings. If I want to look at the relationship between the Google ratings and price, I might think as price goes up, the rating goes up, right? Then I'd have to deal with the fact that there's missing data values, but I'm not looking at relationships, okay? So we're all fine. Okay, so let's go ahead and plot. Histogram, price, and again, I'm going to use frequency. You don't have to put the mean in the median, and you don't have to put the value over the bar. I find it's helpful though. The X label is going to be I'm going to say monthly rent, and that units is US dollars, right? And you can say counts or frequency. I'll say frequency this time. And again, I have to put a thing in, so I'm going to say distribution of apartment prices on Craigslist. I'm just going to put the year in, okay? And we can go ahead and plot that. Okay. And I look at this, okay? So what do you guys think? Tell me what you take away from this plot. Anybody?
I mean, you could definitely tell that it has one mode.
Yes. It's definitely right skewed. Do I have an outlier here? Is this an outlier? It's separated by but not a lot, right? And in fact, if I went back and I changed the bin size a little bit, I'll just do this really quick to make a point. You guys don't have to do this. We started at 500. And if I make the bin width, let's just try 250 really quick. What's going to happen is it'll get absorbed in the tail. Okay, so it's a little a ways, but it's not that much. It's not like Babe Ruth, right? Okay, and there you can see this is, I can draw a nice smooth curve through that in my mind, right? And this is not an outlier. So let's go back and start to, what in the heck? Too many windows open. Okay, so let me go back and I'm just going to start filling in some of the blanks, okay? We'll cut right to the chase here. I'm going to post that in a second, okay? So I'm just going to copy and paste this, and this is what I would advise you guys do to save time. Just make sure you change everything. Okay. There we go. Okay, so the plot of the Craigslist apartment prices is unimodal and right skewed. And most financial data actually is right skewed. Whether you're talking about incomes, whether you're talking about prices of commercial goods or whatever, with no apparent outliers. Now, what should I use? Should I use the mean and standard deviation or the median and the IQR?
Median and IQR.
Yes, why?
Because it's a right skewed.
Bingo. So here, I'm going to use the median because I have skew. And I'm going to go ahead and compute that value. And then for the IQR, for the spread, I'm going to use the IQR for exactly the same reason, because I have skew. And I'm going to go back and compute those. Stat, summary stat, column, always the same thing. That's my variable. Sometimes you'll forget to click on the variable, and when you do, it'll give you like a little snarky thing like, don't you want a variable or something like that? Okay, there's my median and IQR. Okay. So the median's the 50th percentile, right? So I know that 50% of the apartments roughly are less than 875. And my IQR ended up being 305. Okay? And now we're ready to go ahead and finish it off. So the center is given by the median, which is $875. And the width is given by, you can type out interquartile range, but anyone who knows what it means, they always use IQR. Very few people ever write it out. So you can do that. And that's it. Piece of cake, huh? Once you see how to do it, all right? Okay, so I think we have 1 minute left. Is that right? Let me just check my schedule really quick. Yeah. Okay. So what's going to be on the exam? Well, I can tell you. It's going to be this iPads data. So you can practice for the exam. I'll tell you what one of the problems is going to be. There are 4 prices here. This is the total price for college. This is a data set on college. Total price for in-state on campus, out-of-state on campus, in-state off campus, out-of-state off campus. I'm going to give you one of those 4. So you can go ahead and practice that, okay? And they'll all be roughly the same. So if you get it for the one, you're going to figure it out for the others, okay? So, okay. Questions that we have.